Today is our topic. This is a motion in vertical plane. You must have observed that sometime when we rotate any object in a vertical plane, okay, then you have to give some minimum velocity so that the string with which any object is suspended or attached does not bend in the downward direction and it start moving. For example, if you have a bucket full of water, then if you rotate with the minimum velocity, then the water does not spill out of the bucket. So this is the case of motion in vertical plane. We will take the two points A and B. Okay. For example, at point A, the velocity of the object is v1, and at point B, the velocity of the object is v2. Okay. So, as you know that the weight of the body always acts in the downward direction in the both cases. This is mg, which is in the downward direction, and r is the radius of the string with which the any object is attached. Okay, so as you know that when the string is attached, so mg is in the downward direction, and tension is the force which acts towards the center of the circular path. Similarly, in the at point B, it is also in the downward direction. T is the tension at point B and T is the tension at point A, which is acting towards the center of the circular path or circular plane. So we will find the values of V2 and V1. So at point B, if we see at point B, we will find the minimum velocity, that is V2, and it is clear that the total force towards the center is T plus mg, and this total force will provide the necessary centripetal force, and that is mv square upon r, and here the v is v2. Okay, in this way. So at point B, we will find the minimum velocity. So T can be put equal to 0 because only the weight can provide the centripetal force, that is mg will be equal to mv2 square upon r. So you can find that v2 square is equal to g into r. So this is the equation number 1, or you can find the value of v2 will be equal to g into r under root. So this can be taken as equation number 1. Okay. So this is the minimum velocity at point B, means at the uppermost point. Now to find the velocity at point A, means we have to find the velocity v1. Now to find the velocity at point A, we will take the concept of total energy, means as we know that according to the law of conservation of energy, the total energy means total energy at A should be equal to total energy at point B. Okay. So at A, you know that there is only kinetic energy, means at point A only kinetic energy is there because there is no any potential energy as it is suspended from point O, means total energy at A is only kinetic energy. But at point B there is two types of energy, kinetic energy plus potential energy. Why? Because it is having distance 2r. So kinetic energy at A means half mv1 square, because we are talking about the point A, and kinetic energy at point B half mv2 square plus, and what is potential energy? mgh. So mg and h is r plus r, means it will be mg into r. Now we will put the value of half, and m is present in all terms, so m is cancelled up. So here it is v1 upon square upon 2, and half, or we can write here v2 square upon r plus here it will be 2 into gr. Okay, so we have to find the value of v1 square. So v1 square will be equal to, so here LCM will be taken, it is 2, and here we can write v2 square plus here it is 2 into 2, 4 into gr. Okay, now 2 is cancelled with this thing and v1 square will be equal to, value of v2 square is gr. So when I will put with gr plus 4 into gr, it means that v1 square is equal to 5 into gr, that is v1 square is equal to under root 5 gr. Okay, v1 is equal to under root 5 gr. So in this way, at least this type of velocities v2 under root gr should be there, and at point A under root 5 gr velocity should be there, so that the water or the object which is in circular motion does not fall in the downward direction at point B, means at the topmost point. So this is the case of the velocities of the object in circular or in a vertical plane, so that the motion is continuous, and whatever the object you have placed inside that bucket, you can say, or any object, it does not fall in the downward direction. Thank you very much.